In this video, we're going to look at factoring completely a unique type of polynomial called a sum of cubes. And a sum of two cubes is when you have two values that are cubed added together. It's exactly like it sounds. And when we have that, there's a shortcut we can take to actually factor the sum of cubes. There's a pattern it's generally always going to follow. So what we have to determine first when we look at these expressions are these polynomials is, are they in fact a sum or an addition of two different cubed values? So let's look at 15a. 15a, what is it that we're cubing? X. I put parentheses around the x. That helps me out to identify when I get ready to write my factors, because I know x is what I'm cubing. 27y cubed. Well, we know the y is cubed, but can we turn the 27 and convert that into something with a base that's cubed? And the answer is yes, it's 3 cubed. So this is the same as writing 3 cubed y cubed. I can take that and write it like that. 3 to the third, y to the third. 3 cubed y cubed. That's the same thing as 3 cubed y cubed. So what do I do from here? Well, a sum of cubes has a unique pattern. When you have a sum of cubes, you have a cubed plus b cubed. Let's just say two generic things. That means your factors are going to be a plus b times a squared minus ab plus b squared. So whatever my a value is, whatever it is I cubed first, goes here. Then I square that a value, put it here. Multiply it times the b value, goes here. And then the b value that I cubed goes here. I square it here and multiply by the a value in the middle. So what's happening is we're actually creating a pattern of factors here based on knowing our bases, what it is we're actually cubing. So let's look at this one and let's plug in. It's a sum of cubes, so I know I'm going to have my two factors. I know I'm going to have a plus here. I know I'm going to have a minus here. And I know I'm going to have a plus here, because it's a sum of cubes. The difference of cubes is a little bit different. A plus b. What are the two things I'm cubing? X and 3y. So that's what goes here. A squared. What is it that I cubed? X. Well, I'm going to square that, so that becomes x squared. B squared. What is it I'm cubing here? 3y. So I'm going to square it. That's going to give me 9y squared. And then in the middle, it's the product of a and b. So 3 times y times x. So 3xy. And there is my factored form for my sum of cubes. So let's look at b. If I take b, again, the y here is cubed. I know that's going to be y cubed. That's easy enough. And I know the x is going to be cubed, but is 8 a term or a constant that we can convert to a base that has a cube? And actually, yes. We can rewrite the 8 as 2 cubed. So I can write this as 2 cubed x cubed, which the shortcut for that is just to cube the whole thing, 2x. So now I do have a sum of 2 cubes. So let's plug it into the factoring. I have a plus b, which are my two terms. So 2x, that's my a term, plus y, that's my b term. Then here I have a squared, so I'm going to take 2x and square it. That's going to give me 4x squared. And then here I have b squared, which is going to be this value, which is y squared. And that's going to be plus. And then in the middle I have the product of a and b, 2x times y, which is 2xy. And that gives me the value here of my cube. So let's look at the third one. 64x cubed and 125y cubed. 64 can be written as 4 cubed, so I've got 4 cubed x cubed. 125 can be written as 5 cubed, so I've got 5 cubed y cubed. So I'm going to rewrite this as 4x quantity cubed plus 5y quantity cubed, because everything's cubed. Now I can plug it into my formula for factoring a sum of cubes. So my a and my b, 4x plus 5y, that's my a and b term. my a squared, so 4x squared is 16x squared. B squared is going to be 5y squared, so that's going to be 25y squared. That's plus. And then AB goes in the middle, 5y times 4x, and that gives you 20xy. And that is how we factor a sum of cubes. Now let's look at number 16. So we're going to move to number 16. And number 16 is the same thing, factor completely. So let's look at 16a. 16a is negative 2x cubed plus 8x. And we want to factor this completely. So we're going to first look for the GCF. Is there a greatest common factor I can factor out of this? And the answer is yes. I can factor out a 2 and I can factor out an x. So I'm going to take a 2 and an x out. Okay. And that's going to leave me with negative x squared plus 4. Now, if you rearrange these, this is actually a difference of 2 squares. There's 2 different ways you can do this. I can rearrange these terms here. And I can make this 2x. I can make this 4 minus x squared just by switching them, because that's still negative x squared positive 4. And this becomes a difference of 2 squares. So this is actually the same thing as saying 2 squared minus x squared. And if you remember, the difference of squares says when you have a squared minus b squared, the factor is a plus b times a minus b. That's how you factor a difference of squares. So I've got this 2x hanging out here, and I have 2 squared minus x squared on the inside. So what I can do now is I can factor this. This can be 2 plus x times 2 minus x. Just like you do up here, a squared minus b squared, a plus b times a minus b. 2 squared minus x squared equals 2 plus x, 2 minus x. The other thing you could have done is you could have factored out a negative 2, and this would have been x squared minus 4, and you would have had x plus 2x minus 2. Either way would have worked. You would have just had a negative on the outside. Your answer would have looked like this, with the negative 2x factored out. This is also right. If you would have taken the negative 2 out, you would have ended up with x squared minus 4 instead of 4 minus x squared. And this still is the same thing. It's the same as putting the negative in here and factoring it in each of these. Okay. So that's your answer for number 16. Now let's look at 16b. 16b, we have x squared y minus y. Once again, I want to look and see if there's a GCF I can factor out, and the answer is yes, I can factor out a y, and that leaves me with x squared minus 1. What do you recognize x squared minus 1 as? That's right, it's a difference of 2 squares. So I can actually take the x squared minus 1 and factor it as x plus 1 times x minus 1, because this is x squared minus 1 is the same thing as x squared minus 1 squared. Difference of squares is important. You have to learn how to do that one. Okay, and I've got a whole other video on that. So let's do C. C is 4x squared minus 64. So let's look at the GCF. I can factor out a 4, and that leaves me with x squared minus 16. Well, remember, x squared minus 16 is the same thing as x squared minus 4 squared. What is that? Once again, it's a difference of 2 squares because it's a difference. So I'm going to have 4, and I'm going to have x plus 2 times x minus 2. And that is going to be my answer. And that's how you do number 16 using greatest common factor and difference of squares.